Alright, so I thought after last night's class that I would create a little video tutorial that reviews what we went through in class and demonstrates what we didn't get to. Um, so we're looking at Grasshopper here, as we all know, and this is about where we kind of ended up in class at the end of class on Thursday night. We had referenced some curves from Rhino and lofted a surface through them, and then we went through the exercise where we subdivided all those curves a specified number of times and drew a polyline through them all. So that's what we did in class. The stuff we didn't get to, and I'd like to just preview it here, is using that surface as a way to generate some geometry. So the second example we'll go through is drawing a kind of diagonal grid across a surface and being able to specify the number of cells in both the x and y direction. And the third example, which we'll see, is a similar exercise where we use that input surface, and this time we're simply drawing UV curves a specified number of times given a slider. So that's our goal. I'm going to go through this pretty quickly, and hopefully if there are any questions we can pick them up in the comments. So I'm going to start from scratch with a brand new Grasshopper file, and as you can see, I have a small volume here in Rhino and a few guide curves, these green curves. So let's start by referencing those just like we saw last week. I'll start with a curve component here from the Params tab. I'll right click and set multiple curves. Here I'll be careful to select the curves in the order I want the loft to go in. So they'll go 1, 2, 3, and press space when I'm done. And as you can see, all three of those curves are referenced there. To create the loft, we'll go over to the Surface tab, find the loft component, and connect all of the output curves to the input of the loft component here, which asks for section curves. As you can see, we've got a surface here in Grasshopper, and again, just to kind of review the very basics, if I wanted to bake that surface into Rhino, I'd press the space bar and press the little fried egg button here to bake that surface into Rhino. So let's go through the curve subdivision. We're going to divide a curve. Again, that component came from the Curve tab division section. And we already have the curve we want to divide. In this case, it's a list of curves. And you can see that there's a default value set here. We're going to want to specify the number of divisions. So I'll grab a number slider. Again, that's Params tab special section. And I'll right click this to edit it. As we discussed the other night, we're going to want integers so we can get a whole number of divisions along these curves. And let's go from 1 to, let's say, 100. And I just double clicked this little roller bar here to enter a number. Press OK. And that'll be our number of divisions. 1 obviously gives us just 2 points at the end, and there are our points going along those curves. I'll hide the loft, and if you'll remember what we did here, we wanted to draw polylines from the kind of across the span of the little roof we're modeling here. And we went through this in class, but just to demonstrate it again, if I try and draw a polyline using the output points, which we have right here, I'll get polylines that go through all of the points. And again, just to go through the difference between lists and data trees, as you can see, we started with a list of curves. three curves, and all of them were subdivided. So Grasshopper will give us all of those subdivision points in a data tree is what it's called, and it's essentially a list of lists. In this case, we're dealing with three lists, each of which contain 22 items, 22 points. And essentially what we want to do is draw polylines that go from the 0th point in each list. So 0 to 0 to 0, 1 to 1 to 1, 2 to 2 to 2, etc. And what's happening right now, as you can see, is we're just drawing polylines through the list. So there's an easy fix for this one, and we get this from the sets component ribbon section here, tree section. Flip matrix is the component we're looking for. We'll input all the points, and then we'll try and draw that polyline again using the flipped tree. And there you go. So now you can see if I plug this data tree into these two components, that the number of branches I'm getting corresponds to the slider setting, and the number of points in each list is 3 because we're always dealing with 3 curves. Okay, that pretty much wraps up the first example. So for the next one, and just maybe to go back, the goal here is to end up with a diagonal grid going across this surface. And we'll start that back here in our other file. I can hide everything we've been working on so far. And I'll start by grabbing a surface node out of the geometry section, and we're going to use the lofted surface as the beginning for all of our downstream operations. I'm going to hide the wire here. I just right-clicked the component. I'm going to select Hidden Display, and I'll also hide the surface to start. So the way we're going to do this is we're going to divide that surface up by a specified number of points into small subsurfaces. This is done by treating the entire surface as a continuous domain. We've talked about this a little bit in class, but essentially the UV domain is the domain we're talking about now. And we're going to divide that domain a specified number of times. That component came from the Math tab domain section, divide domain. So the domain we're working with is the surface. I'll plug that into I, which is the base domain. And the number of segments in the U and V directions we'll use sliders. I'm just going to copy and paste these integer sliders from up here and connect them to U and V. So just to kind of track our progress, what we're looking at here is a list of UV subdomains, and that'll become clear later, but suffice it to say that we're inputting 7 and 7, and we're getting 49 subdomains, so that makes sense. The next component we'll need is out of the Surface tab, and it is in this Utility section, IsoTrim. This extracts an isoparametric subset of a surface. So it's asking us for a base surface and a domain of the subset, and the base surface will be our original lofted surface from above, and the subset will be this list of individual domains. And there they are. You can see that as I increase the slider count here, the number of these subsurfaces increases or decreases correspondingly. So let's set this down to a kind of low number so that it runs pretty quickly. And now what I want to do is use these subsurfaces as a way to draw some some lines essentially. And we're going for an X grid, so I'll be trying to draw lines from kind of opposite corners of these subsurfaces. The way I'll do that, and this is, I think we demonstrated this really quickly, but just like we can build up bigger data structures, like building up lofts from curves, once we get some bigger lists of geometry that we want to decompose, Grasshopper will let us do that too. So since we're dealing with surfaces, we'll go right over here to the Surface tab, and there's this BREP Components node that I'll grab from the Analysis section. This will give us a list of all the points, edges, and faces, edges, and vertices that build up all of these subsurfaces. And we're most interested in the vertices because we want to draw lines. We want to draw lines from kind of corner to corner, so we'll use those points as a way to do that. So in order to draw the lines, we're going to we have to figure out which points are which here, and I'll use the list item that we demoed in class the other night. Again, this is under the sets section in the list component. We're dealing with the vertices, and you can see already I'm selecting a few, and I'm going to use just a little panel as a way to specify which one I want. So we know that Grasshopper starts counting from zeros, and there's going to be 4 points per surface, so it'll go something like 0, 1, 2, 3, and that's exactly what we'll do with these little list components. So I'll just copy and paste these a couple of times and then change my input values. 1, 2, 3. I'm just double clicking. So now when we select these, it's a little hard to see when you have them all selected at once, but those are the individual points on each one of these faces, and now we'll start drawing some lines. So I'll grab a line component out of the Curve tab primitive section. It's right here, the line between 2 points. And let's start just by going from 0 to 2. Alright, so you can see what's happening here. Let's say that this point, if we just look at this one surface, this one subsurface, let's call this point 0 and go around. So it's drawing a point from 0, 0.1 to 0.2. And the next one we'll draw is from 0.1 to 0.3. Alright, so now let's just hide everything in the middle here, and I think you'll see now that we have a pretty functional definition working. We should be able to increase and decrease the count along both the U and V directions. And of course, since this is all working parametrically now. Okay, so we're back. Sorry for the abrupt break. I just found that when I pressed F10, it stopped my recording and didn't turn on my control points like I wanted. So what I was going to show here was that if I turn on the control points of this curve, since everything's referenced downstream, I can very easily kind of change the geometry of my roof very, very quickly just by controlling that one input curve. And now that I have control over the subdivision, you can see that I've enabled quite a powerful parametric workflow here without much Grasshopper logic. Okay, so that wraps up the second exercise, and let's just hide those lines for now. The last example I want to show, and I'll go back to my other demo file, is using the original lofted surface and drawing isoparametric UV curves a specified number of times along the surface. Alright, so let's go back to the other file and we'll give that a shot. So again, all we need as an input for this should be the original lofted surface. I'll just copy and paste this component. We'll start another little chapter down here. The way that we're going to do this is we're gonna use a similar strategy to what we did with the subsurfaces. We're going to, out of the surface tab, we're going to grab one of these brep components nodes and we'll explode this surface into its component faces, edges, and vertices. So the idea here is that we're going to draw some points along the edges to specify where we want to draw the corresponding UV curves. So let's use the edges that we already have as those curves to divide. So just to kind of make this fast, I'll start with we'll do the same thing. We're just retrieving a specified item out of the list of edges. So there's the one that runs in the X direction, and I suspect that number one will be the first one running in the Y direction. Yeah, so that'll work. I'm going to divide those curves up using the same method that we used up in the first section. So curve divide. And this time I'm going to have individual sliders. I don't want the same number of subdivisions along both points. So I have a couple of integer sliders here, and that's what we need. And I will just input those into the N input here, the number of segments for division. Okay, so you can see that that's working. The lower number here corresponds to my y-axis. This upper one does the short. Now that we have these points, let's try and draw a U curve and a V curve from each one of them all the way across the surface. That is done using this component right here, the create isocurves on the surface. This is from the curve section spline subsection. So it's asking us for a surface to draw on and coordinate on surface for isocurve extraction. And this is a point, but what it's really looking for is a UV point. So we know the base surface, that's our original lofted surface from above. And if I try to just input a point, let's see if this will work. Kind of. See, we're getting an error here, and maybe if I reparameterize this, no. See, what's happening is we're giving it points that are kind of specified in X, Y, Z space, and this component's expecting UV points. We'll get into this a lot more in the next class, but for now I'm just going to show you the method I use to extract these UV points. So let's keep this and we'll try and make sure this is working correctly. So if we go into the Surface tab, there is, in the Analysis section, there's a component that will find the closest point on a surface from any given point. So it's asking us for a sample point and a base surface. The base surface is going to be our lofted surface, and the sample points are going to be all of these division points that we generated with the division component. And it'll give us output points, and in this case they should be essentially identical. But what this also gives us is UV coordinates. And if I input this into the isocurve, you can see that it's working properly now. I'm drawing a point from each one of these U and V curves along the surface. And you'll notice that it's outputting both curves in the U and V direction So just to make sure that I'm getting the right direction ones, I will use just a generic curve component, and um, it looks like it's going to be the V curves in this case that are running along the surface. So we'll do that exact same thing. I'll take all of these components and copy and paste them. And the only thing that changes is the input points in this direction. And now the output curves should be the U's. So if I hide everything kind of upstream here, including the exploded or the components, UV components node there, you can see that I'm left only with curves running along the U and V directions of the surface. And again, if I kind of adjust my slider values, I'm generating new series of curves on the fly. So I think a few of you who, the ones who did the boats and a couple of the benches for your multi-section geometry assignments, you can see that this method is a really powerful way to explore the number of ribs and then kind of secondary or ribs going in the other direction. Okay, so that's about it. If there are any questions, please post them in comments or feel free to write me an email, and we will pick it up next week.